Aloha and welcome to our video on the vast world ocean. In this video, we will recognize that most of the Earth's surface is covered by water. We'll look at the four main ocean basins, and then we'll talk about how technology has allowed us to see the topography of the ocean floor. Okay, so to begin, if we take a look at our planet, here we have a polar view of our planet. So we can look from the North Pole or we can look from the South Pole. And what we notice is we see an awful lot of blue. There's a lot more blue in the southern hemisphere than there is in the northern hemisphere. But what we notice is about 71% of the Earth's surface is covered with the oceans. So they're a very important thing to our planet. So let's take a little bit of a deeper look inside of them. Now, when we're talking about our oceans, we realize that we have four primary ocean basins, and that would be like the deepest part, the collections for the waters to be in. The largest by far is going to be this one over here, which will start on that side and kind of finish up on this side, and that's our Pacific Ocean. That's the largest ocean that we have. By size, the next one is going to be the Atlantic Ocean, and notice both of these oceans tend to extend in the northern and southern hemisphere. Remember, our hemispheres are divided by this equator here, so we can see that we have two primarily large oceans. We also have the Indian Ocean, which is over here, and while it's about the same size as the Atlantic Ocean, notice it's primarily a southern ocean. It's primarily in the southern hemisphere. And then our last is this teeny tiny little one up here called the Arctic Ocean, and that's only about maybe 6 or 7% of the Pacific Ocean's volume, so it's a lot smaller than the other three. Okay, so what does the bottom of the ocean look like? What does the ocean floor look like? Is it flat? Is it bumpy? Does it have characteristics and features? Is it just a vast wasteland? These were questions we didn't really know an answer to until about 100 years ago. Prior to that, what we did is we found our depth with soundings. So you would take a string and it would have these colored ribbons marked off every few fathoms, and they would throw that over the side of the boat and wait for it to hit the bottom, and then they would count how many ribbons had gone past or look at the color and determine how deep it was, and then they'd yell how deep the ocean was at that point. So shallow areas, it was really easy to measure depth because you could take a piece of rope with you and do this. But once we got out into the middle of the oceans, out in these areas here, it was too deep for that rope to reach. So we did a lot of observing and we did a lot of inferring and we tried to figure out what the bottoms look like. And what they felt is like if you dig a hole on the side of the beach, what you'll notice is that you kind of get this flat bottom that you see there out of the sand. And that's what they thought the bottoms of the oceans were like. So that's what we assumed it would be. In the 20s, we discovered sonar, and we used that sonar to help us find submarines. After World War II, what we did is we came back across the Atlantic from Europe. We brought our boats back to America, and as we did so, they said, hey, let's turn on the sonar and see what we can find. And as they shot down to the bottom, they found that there were these huge mountain ranges that were underwater. And they found that there were caverns and canyons underwater. And we noticed that the bottom of the ocean wasn't flat at all. In fact, it was covered with all kinds of topography. And we did this by sonar initially, and we've had more developing technology, and we'll show you this a little bit later on in the video. But this is how we discovered this mid-oceanic ridge that we see running down the Atlantic. And we see another one over here in the Indian Ocean. So we've seen that there are topography, there's things on the bottom of the ocean. So it's not that flat wasteland that we used to think, but instead it's this topographic rich area. Okay, let's talk a little bit about this sonar and how it works. Now, with sonar, what we have is we have a ship here, a vessel, which is going to emit an outgoing signal. It's going to create a sound and send that sound wave out from the boat. And you can see that sound wave traveling from the bottom of the boat down to the bottom of the ocean there. When that sound wave hits the bottom of the ocean, it's going to bounce off the bottom of the ocean, and we create what we call a reflected signal, and that reflected signal is going to bounce back up to the ship. And that allows us some very important information. What we can do is figure out the time that it takes for that signal to bounce from the ship down to the bottom of the ocean and back. So we're timing it from here all the way till that signal gets back to the ship. When we have that time, we're going to divide it by 2. And the reason we divide it by 2 is because that sound has traveled all the way to the bottom and then back all the way to the top. So it's traveled that distance twice. When we divide it by 2 and we multiply it by the speed of sound in water, what that gives us is the depth of the ocean. And that's quite simply all we're doing to find the depth using sonar. Now, recently, we've worked on sonar, we've gotten better, and instead of having just this single ping that goes down and comes back up like we see here, we can have a multi-array beam. So we'll send out actually multiple beams of sound this way, and then they come back, and that allows us to paint a bigger picture of the ocean floor. So that's how we use sound to map the bottom of the oceans. And that worked for us for a long period of time until we discovered another method. Our current method of mapping the ocean's floors is done with a satellite. And that satellite, as it's orbiting around the Earth, is going to send down a radar pulse. Now, sonar uses sound, radar pulse uses radio waves. And this radar pulse will come down just like it did from the boat, and then it'll bounce back up to the satellite. And once again, we can calculate the distance and all of that. But what we're looking for is we're looking for this change in elevation of the surface height. So we're looking at the ocean over a broad area and seeing how that ocean is distorted. And that ocean gets distorted based on what's on the bottom of the ocean. So if the bottom of the ocean has a mountain, let's say, on the bottom of it like this, what we'll notice is that the ocean's surface will kind of go like this, and it will bulge over where that mountain is. And that's what our satellites are able to check. Our satellites will be out there, and they'll have the ability to go through, and they'll send down this radio wave, and they'll measure that there's this slight gap here. And by doing this far enough and knowing how tall one of these is, we can extrapolate that information out, and that's how we make our current maps of the ocean floor. Okay, so that's it for our Vast World Oceans video. As always, good luck on the lessons and the quizzes, and we will see you in the next video.